just to kind of do a couple of housekeeping items, everyone's phone is muted at the moment. So if you have any questions, please feel free to enter them into the questions tab that you'll see within GoToMeeting, or GoToWebinar, I should say. The expectation for this particular private webinar is to be really informal. So unlike most of the past webinars that you've seen from Input Ace, where I or one of my colleagues have walked through a series of really structured steps, my intent here is just to provide you all with a good specific overview of how to use the overlay tool and some of the questions that I'm expecting that you will have once you begin to dive in. For anyone who hasn't yet had a chance to dive in, you all should already have a link to download the latest version of the Input Ace beta. If you don't, or if that email's been misplaced, please don't hesitate to reach out and we'll make sure we get you up to speed. But my hope is that by the end of this next probably 30 to maybe 45 minutes at most, that I will be able to bring you up to speed and get you off to the races and running so that you can get a chance to use the tool prior to our launch date. And of course, we do ask, and we really appreciate the assistance of our beta testers. And if you find anything that you think is either confusing or not well worded or not intuitive enough, or flat out you encounter some sort of issue with the program, please do let us know. Our hope is that we can work together with the beta testers to really polish things off before we release the tool to the public. With the email that was sent out with the overlay download, you should have also received a sample project. Now, the project is quite large, the 3D project, so please don't hesitate to use your own data as a test. The only reason that this project has been sent out is that we had a number of requests for some sample data from case work that we've already done in this office. So feel free to use that sample data if you'd like. Please do not distribute it. As mentioned in the email, this is a data set from a case that's been adjudicated already, but we still need to make sure that it doesn't leave the hands of the people that we've gotten permission to send it to. Okay, so that all said, what you're seeing here on my screen that you should see now is a fairly large point cloud, at least large relatively from the kinds of data that we normally deal with in our office at least. And with this data, you will have also received the original video file in question in this case, which is a .exe file. And I'm going to go open that up now. That .exe file should look something like this. And of course, if you double click on and open this, it will open up inside of a proprietary player. But what we're going to do today is a series of steps to take that video data and calibrate it on top of the point cloud by taking that .exe file into Input Ace. At this step, for anyone who has not yet attended an Input Ace training class, for anyone who has taken the training class, I should say, you'll probably key in automatically on the aspect ratio of the image and the dimensions being something like 720 by 240. We cover this in great detail in the class, and I've even got additional training webinars that go over this. But that data needs to be resized up to double the height of that image before it should be calibrated on top of the data. I'm not going to go into the technical reasons why on this webinar. I see that most of the people that are attending the presentation have already taken Input Ace 2-day class. And if you haven't yet, there is more resources, again, available on YouTube that cover this topic. So that said, what I'm going to walk through, we could do a calibration of any one of these 4 cameras by taking that data, going through the steps that we're about to use on the tools page. But before I get there, let's take a quick look at the scenery in question. This particular case involves a collision that occurs in one of the lanes here, right in this middle lane near the area of the intersection. And if I go back to the video, you can actually see that very minimally here in the background. If I play forward in real time, we'll see a bus appear on the image right here, traveling from right to left and strike the back end of a vehicle. Again, it's in the distance. I'm going to go back in time here, frame by frame forward, and we can see the effect of the sparks that appear here after the impact. So one of the primary questions on a case like this is going to be distance and time to get the speed of the vehicle and to provide any perspectives that the bus driver could have had during the incident. So that all said, we've got this camera here. We've got another camera that's facing another direction. This is a little bit further to the right of the front of the building. If we go forward frame by frame, we can see that same bus driving from right to left. That goes through the intersection and then out of view off to the left-hand side. And then on the third stream, excuse me, the fourth stream here, we see that same bus appear moving from right to left through this area. Now going through that, let's take a quick look at the point cloud in question. And we can see that we have the building where the cameras are mounted right here. We have the intersection, and we have the area where the impact occurs right in this lane. So if I zoom in to the building, and my expectation is that based on the files that were submitted, I know that they were scanned with a Faro laser scanner. The same exact process exists when scanning with Leica or with any of the other tools. Once you've created your 3D point cloud within whatever your preferred point cloud tool is, you can navigate around, and we will see that one of the cameras is located right here. This particular camera perspective is the same camera as stream number 1, which is visible here. So if we look back to the camera inside of the point cloud and we get, roughly up above the camera, we can see that this area is the same area that we're seeing here on the video. From there, if we fly back up and overhead, we can see a couple of additional cameras that are present on the front of the building. And those cameras are going to be from video stream number 2. It's this camera angle right here, facing off to the right side of the roadway. And back inside of the point cloud here, if we fly around to the building, we can see that the camera that we're interested in is mounted right up in here. So in fact, if I zoom up into the camera and I pivot around to provide us with a perspective aiming roughly in that same direction, and we're going to get a little bit more precise momentarily here, but we can see the parking lots and the way that the gas pumps appear. And if I go back into my video, we can see that same perspective. We have the parking area and the gas pumps. The reason that we've sent this data set is because it provides a really broad approach where you now have access to a single point cloud that has 3 primary cameras that we can calibrate to. And just to make sure that I jump into the practical purpose of this webinar, I'm gonna focus primarily on this camera right here, which is going to be video stream number 2 in question. And so I'm going to walk through kind of a live calibration and overlay from this perspective. And I'm going to do my best to pull up some saved files so that you're not watching me click repeated monotonous buttons for the 5 minutes that it would normally take. So when trying to get this data calibrated, the very first thing that I'm going to do is create a clip of video. Instead of calibrating the entire sequence, which can take some time, I'm going to just calibrate the area where the vehicle that we're primarily interested in is present on the image. So to create a clip, everyone should very likely be aware of how to do that so far. Strike the I key to mark an in, play through the relevant area. I'm just using my arrow keys to go frame by frame forward. And then once that bus is out of view off to the left, I'm going to mark my out with my O key and then my S key to make my clip. Now that I have my clip, what I would like to do now is resize the image as discussed to double the height of the image. And on the workflow tab, I'm going to do that by creating a filter called resize, connecting my clip here to the resize node by clicking and dragging from the connection area, going into the settings of resize and doubling the height here to 480. Again, this is a topic that's covered in detail in the class, but when doing a correction like this on this type of file, I'd recommend choosing nearest neighbor. I'm going to gloss over the reasons why for that purpose for now. And then I'm going to save a final exhibit here, just as an MP4 file as an example. And I'm going to name this file here my clip. And I'm going to send the outputs back into the file list when they're done being processed. And by connecting the dots and pressing execute now, we're done. So that quickly now we've got our new clip that has been corrected, containing just the sequence of interest where the vehicle is driving through the scene. What I'm ready to do now is to begin the process of going to the Tools page and launching into the Camera Match overlay. Again, there is a full hour-long webinar that I expect each of you have already watched that covers the kind of the technical background about how margin of error is calculated and what the purpose of this tool is. So I'm really going to stick mostly to any of the questions that I expect you're going to have. And again, just to reiterate, please don't hesitate to post questions while I'm going through this. My expectation is that everyone will walk away from this webinar with the ability of actually doing this on your own. First thing to mention once you get to the camera match overlay tool is that there's a how to use this step button that's present in the bottom left-hand corner of the tool. And this area, if you expand it open, will provide a pretty, I hope at least, intuitive text-based description about what to do on this tool, or this step, I should say. So once you're on this step, what it will tell you to do here is to load in a background image and to load in the original video. And by original video in this case, we really do mean any of the clips that you're looking at calibrating. So if I'm only looking at calibrating that short sequence, I'm going to be able to drag and drop my clip into the original video location, and it's now populated that area on the right-hand side. The next thing I need to do here is to load the background image. And the background image is meant to be the perspective from the camera inside of your 3D point cloud, assuming that you're doing this process with a point cloud. And starting this case, it might take some time to identify where the camera perspective is by looking at the view and what's available. And that process I've kind of already given us a bit of a head start on by identifying this camera as being the camera in question. And so now comes probably the very first step that is a manual process within this workflow, and that is to create a viewpoint at the perspective of the camera lens. That can be done a couple of different ways. That can be done manually by, of course, flying in from behind the camera and trying to get as close as we can to the center of the camera area. So if I go into the center of the lens, and then once I'm in the area of the lens like this, we can potentially change any of the field of view. And I'm using a particular 3D point cloud program here that is a bit of an antiquated, outdated one. It's just mostly just to show how this was done on this particular case. I would expect that you're going to be using whatever point cloud tool you're most comfortable with. And I suspect that most of the people that I'm seeing on here are either using Cyclone from Leica or Ferrozone or even Scene to do this process. But any point cloud tool that provides you with the ability of visualizing in 3D and setting the field of view is all you'll really need to do this process. Now, this process, again, as I mentioned, is a little bit of a manual step. What we're going to be doing here is trying to get our point cloud camera to match as closely as we can the camera perspective that we see here. Keeping in mind, of course, that this particular camera view has lens distortion. In other words, some of the objects are going to become curved in this image, and we're going to be correcting that on one of the future steps within the tool. So for now, we're just trying to get as close as we possibly can. And one of the really big benefits of using the camera match overlay tool within Input Ace is that we do not have a requirement to be at the exact camera perspective when we create our background image. Of course, we want to get as close as we can, but when we are off in a minimal way, the side effect is simply going to be a larger margin of error. So it's recommended that you spend as much time as you can to get this perspective as close as you can, just keeping in mind that however far off you are when you create this background image, that's going to relate directly to the margin of error that's calculated in the final result. So I've done this process already by nudging this around back and forth. And again, this might take you a few minutes to nudge this around, maybe changing the angle, trying to get this as close as we can to this particular perspective. And I've already done that here with this particular image. So this is me nudging myself into a saved camera perspective. And you can see how close I was just by eyeballing it within, a few seconds here. But I'd recommend that you take a little more time to get close. So now when we look at this image, we can see that we've got a wider area around the image than is necessary, but at least we have roughly the correct focal view and roughly the correct angle from the camera. Now that this process is done and I've recreated my camera perspective inside of my 3D point cloud, what I need to do now is take a screenshot of this perspective. And you can take that screenshot with any tool that you have access to. That could be the snipping tool that comes by default on Windows 10. So if you type in snip, there's a snipping tool that's present. And in fact, I think this is present on Windows 7 as well. I should say, actually, I'm using a Windows 7 computer, so it is present on Windows 7 as well. And this snipping tool allows you to click and drag an area that you want to take a screenshot from. There's another tool that I like to use called Snagit. This tool has a cost. It's about $50, I want to say, but it has a benefit of being able to snap automatically to different windows, and is a little bit more of a fine-tuned screenshot tool. So if you have the additional $50 on hand, this is a nice little benefit to the workflow process. So what I'm going to do now is simply click the mouse, take that screenshot, and I will save my image here just as a screenshot image. And now I've done and completed the very first manual process for this procedure. So step one, I've loaded in my original video, and I'm going to load in my background image by bringing in that screenshot of my right-hand camera. And step one is now done. Next, we're going to go on to step two. And step two is a process to correct the lens distortion in the image. So if you read through the text here once you have some time, what you'll see is we're going to be looking for areas of the image that currently appear curved but should be straight objects. So for example, if we look at the area around this section of the image right here, we have inside of our point cloud a straight line. Inside of our image, we have now what appears to be a curved line. So what we're going to do is select objects like that, objects that currently appear curved but should be straight. And we select them by zooming in and out with the mouse wheel, holding down the control key, and clicking the mouse to select a point. And we're going to select points along the curve, as closely to the curve as we can. And we're just going to go forward kind of quickly here to make sure that we don't spend too much time. And we're going to end that process by double-clicking our last point. And we'll see here that a line has been created and distortion coefficients have now been calculated from that one single line. It's usually recommended to pick about 3 lines, as you see here in the description. So I'm going to do that process yet again, and this time I'm going to click up along, how about this line right here that appears curved but should not be curved. So I'm going to be clicking along the line in the same way, holding down control, clicking the mouse, and that one didn't look very good. So I'm gonna want to remove that point, and I can do that by zooming in, holding down control, and right-clicking my mouse to remove that point. So now again I've just got these 2 points. I'm going to zoom back in with my mouse wheel, click my left mouse to select the point, and then on this final one, double-click to lock in that particular line. And then the third line, I'm going to pick the edge of the building here again so you can see how curved this object looks, whereas in the point cloud, it's a nice, flat, straight object. So I'm going to do that last process here again. Control-click, 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 and Control double-click to finalize the line. Okay, now that we've got our 3 lines, we can see our distortion coefficients have been calculated. And we can take a quick preview to see what the final distortion correction is going to look like by pressing the preview button, and it will launch open a new window where we can see what the correction will look like. And so this is a bit of a visual check here to take a quick look and make sure that the objects do indeed appear straight where they should be straight. And if we want to override this, we can override this by adjusting the slider in any way that we might want. The reason that this override exists is primarily for the purpose where the center of the distortion is not in the center of the image. And what I mean by that is the automatic distortion correction is going to assume that the distortion is happening from the center of the image. And we've found that some cameras do not have a distortion that is from the center of the image. In fact, we ran into that same issue at the the FSM conference, the IAFSM, where one of the cameras there had a non-center of distortion. So we were able to override that by changing the center of the distortion here, but it is a bit more of a manual process where we type in the X and Y coordinate that we want the distortion to derive from. So here you have the ability of manually overriding that if you choose to, even by changing the slider here. So for example, if you have a severely fisheye lens, we'll be correcting that in a much more profound way, keeping in mind that the fisheye lenses will require that you isolate a particular region of interest, because the correction for a fisheye is not going to be able to be stretched out completely uniform across the whole image. But if you have a region of interest that's in a particular area, that's how you would do that process. So let's say I set a new calibration based on whatever made sense here. We can override these two values by pressing the set new calibration. But in this case, I'm actually just going to close this down and leave my original calculated distortion coefficients. Once that step 2 is done, we're going to now press next and go on to step 3. So what we'll see here now is that we've corrected our original video image. And now we get into the process that will probably take the longest amount of time in this workflow. This should take about, between 2 and 5 minutes, I would estimate, to select essentially registration points. This process here to set like these correspondence points will be a process of zooming into either the image. Again, I'm using the mouse wheel to zoom in. If I move my mouse onto this side, the same zooming in action will zoom in on this particular view. And we're now going to be selecting similar like points. So if I zoom in and zoom in, we can get the ability of, again, holding down our control key and clicking on points that are the same between our left hand and our right hand image. And that can be as simple as something like clicking on here and clicking on the center of the base, choosing the intersection potentially between this area and this area here. And I'm just going to do this very quickly and roughly, and then I'm going to load up a version where I've spent a little bit more time on this. So you can see here as we go through, zooming in and out, holding down the control key and left clicking, and holding down the control key and left clicking. Okay, so I'd recommend that you get the experience of going through and doing this process yourself. Instead of boring you all by spending the 5 minutes to do this process, I'm going to load a previously saved calibration, which brings me to my next point here. After you've gone through and selected your calibration points, I would recommend that you come up to Options and choose Save Your Camera Match File. There are a few different types of files that we can create, save, and load from the Camera Match tool. The first one that I'm going to mention is the Camera Match file. And that is the file that can recreate the entire calibration process to batch process this on video files or recreate our work for reproducibility's sake or even for disclosure's sake. So what I have done already before this webinar here is I've done this process already where I've gone through, I've selected the points, and I had saved them. So now I'm going to load that camera match file, which is present right here. So now that I've loaded the file here, it's going to take a few moments to load in. I'm going to go back here to my match point step that we were on, and you can see that I spent a little bit of extra time picking out about 36 different points. You can see how closely I've picked these all around. And it's required that we pick at least 4 points, but I think what you'll notice is that if you pick too few, it'll be quite visibly obvious that you haven't picked enough when you go on to the next step, which is a bit of a confirmation step. And there will be a particular point where picking too many points becomes a bit of diminishing returns. So this will become a process that I think just takes some experience to really lock down. But you'll see what it looks like on the next step once we get down to here. So I'd recommend going through that step yourself and really feeling what it's like to set these correspondence points. Now that step 3 is done and I've picked the points that I want to use, I'm going to choose my next key. And I'm sorry, right before I do that, if you have a point pair that you do not want to have, you can select it from the area along the list here and use the delete key on your keyboard to remove that from the list. And you can see that the numerical value is associated here as well. So number 8 in the list is this number 8, and we could delete that point if we realize that it's causing us issues. Once I press my next key, you will see the calibration then animate on top of the other image. I should just say slide on top of the other image. And now we're on to step 4. Step 4 is a process that will start by looking like this, where we can see the entirety of the image. The reason that step 4 exists is to crop out the outer edges. And the reason for cropping out the outer edges here is that it's expected that the outer edges will have a significant lower accuracy than the rest of the image does. And we can even see that with a bit of a waviness that appears here in the pole in the background. And the expectation is that the outer edges are going to have significantly higher margins of error and significantly lower quality data. And so I really do recommend cropping those out and really isolating it to the area of interest and dealing with a final square shape that takes into consideration the areas that are really locked down. So if I go back to my previous step here, and we can see some of the nuances here about what's occurring, it'll allow us to really fine-tune that process. What you might notice as well is that if I were to set a random point here, I'm going to set an incorrect point. So I'm going to choose, how about that point, and I'm going to map it to over here. It should be very obvious when you go to your next step that there is something wrong going on with the image. So if you see a swirling effect or you see a really warped area, it's probably a good sign to go see what point is pushing that object up into that area. And if we go back and we look at the area in question, which is this area right here, it should be pretty quick for us to identify that point number 37 is probably a bad point, and I probably should come back to the list and remove that from my list. And then now when I go back forward again to my crop step, we'll see that that swirling effect is now gone, and we're dealing back again with data that's a little bit more fine-tuned. The steps that you have here on the right-hand side allow us to turn our crop area on and off, and the crop area is the green kind of outline that allows us to set our crop region to the right or to the left. And we can also set a transparency to our overlay to go back and forth to see how close we are to our calibration, so we can modify this as needed when we go back and forth. So once we're done with setting our square shape, if we decide to add in any cropping, we're now ready to go on to our next step, which usually is to calculate the margin of error in the image. I went through significant additional detail on our 1 hour long webinar on this topic, so I'm going to gloss through this pretty quickly here. But the 3 steps for calculating the margin of error starts with identifying the potential error in the scanning device itself. Again, as discussed in the webinar, the way that this is done is to do control measurements on scene. So this could be doing tape measurements, this could be doing additional laser measurements on scene, and finding out what the distance between 2 objects is, and then mirroring those same measurements inside of the point cloud to find out what the difference is. In this particular example, the difference was 0.005 feet, which basically means that for every foot we measure, we're going to be 0.005 feet off for the accuracy of our scanning device. Once I go to my next image here, this area is going to appear pretty redundant to people that go through this process the first time. In this step, we're redoing the point picking between our 2 images. And the purpose for this is because the initial time going through the point picking, we were doing that on the lens corrected image. And on this image, we were doing it before the lens correction. And what it's going to allow us to do is identify the differences between how a single pixel is being calibrated through that lens distortion correction and how far off we can be when we redo that process. It helps to attribute in any human error that can come from this process, and will allow us to identify how accurate the actual calibration process it is. I have a question that came in about if you've already scanned the scene and cannot go back out to do validation measurements, what do you suggest that we do? And I can say that back on step 1 here of the margin of error correction, we are really careful to set a broad margin of error, at least for us internally here. And so the process that's recommended here does provide a significantly wider margin of error than is probably even necessary, but it does allow us to feel more confident when we're saying what the range of margin of error can be. Another approach that I know many offices take, which I'm not saying is a bad approach, I just think that the way that we're recommending is much broader. But another potential approach here is to simply look at the manufacturer's rating on their scanning device and to report that as your potential scanning error. In addition, any of the potential error that can come in from registration between multiple scans, if you use that as your potential error, I think that you are safe in having a way to state that. I personally prefer to go broader and to do those calibration steps. It really allows us to ensure that we're encompassing every potential source of error as it relates to the scanning device. Okay, so that said, back onto step 2 here. This is where we're going to recreate those steps. I'm going to do this very quickly here. I'm only going to pick a couple of points. I recommend that you go through and pick a larger number of points than I'm about to do right now. But I'm just going to pick a few points here, kind of around the area of interest, being in the area of the roadway. And so I'm just going to pick about probably 4 points, and then I'm going to stop. And we might end up getting a very wide margin of error because I'm really not doing this very carefully. But what you'll see here when I go on to the next step is our final margin of error step, which is to assess the amount of error that comes from the image resolution. So again, this is covered in much more detail in the webinar, but by image resolution, what we're talking about is in the area of the roadway, in the area of interest, how much distance passes for the pixels in that area of interest. So what we want to do right now is measure the object in terms of pixels, or measure an area of interest in terms of pixels, and then measure that same area in terms of feet to identify how many pixels per foot we have in the target area. And it would be really easy if we had objects in the area of interest on the roadway that we could simply measure, but we don't in this case. So what we're going to want to do is find an area as close to the area of interest as possible and measure that object, but ensuring that our distance measurement is happening at the area of the roadway. So what I mean by that is we have the distance here between these two different poles, but if I were to look at the distance between those two poles by going from, roughly, let me get down into the area, from roughly here, that distance from there to the other side, we can see that that distance is roughly 25.45 feet. But the problem is, if I were to say how many pixels exist between there, I don't want to know the distance between those objects. I want to know the distance out in the area of the roadway. So the way that we do that is we project from those 2 points back to the camera itself. So if I go back to the area of my camera, which is right about here, and I create a line coming from the center of the camera, going out into space and intersecting at the edge of that line, I've now created a straight line that I can then project out into space. So really quick to help me with this particular tool allows me to remove my data and leave my annotations in. And I'm going to basically extend my line now by selecting the line and extending it into space. And now what I'm going to do is take that all the way out to the area of the roadway, and then I'm going to do the same thing from the other end of my line. So if I hide my data and I create an additional line from the center of the camera lens over to there, I can then project that line back out into space. And I can now see that if I take that all the way out to the area of the roadway, I can measure between those two lines, which again, I've done very, very quickly here. I would want to make sure that I've done that with a little more specificity typically. But now we can see that what we've got is essentially a cone going out into space, where at the area of interest in the background, we've got about 67.88 feet for the same 25.45 feet that we have over here. Now, what that means translated into step 3 of the margin of error calculation, essentially what I'm saying is the line right here in pixels, which I create by zooming into my image again, holding down Control and clicking a point, and then holding down Control and clicking my second point, it's now going to ask me the distance for that line. And what I don't want to do is say the distance for the short line at the 25 feet, because what I want to do is assess the distance for the line all the way back in the background where I'm going to be doing my measurements. So if I type that in here back in input A's, it was 67.88 feet. So we'll say that's 67.88 feet. And now we can see the calibration accuracy and the resolution accuracy automatically calculated here. Okay, so I recommend that you go through and do that in any of the areas of interest that you are going to be doing your measurements from. And once you say the Save button, I've got a margin of error creation that I've already done for this with a little bit more detail. I'm going to just call this one my margin of error 2, so we can take a look at the comparison between the two of those things. And if I go down into my my folder that I've saved these out, we can see the one that I just created called margin of error 2 has just that one single line. And we can see basically that what this is expecting that we're going to do is take our scanner accuracy, which is right here as our final calculation of margin of error, and we need to calculate the scanner accuracy by determining the distance from the camera times 0.005 feet. So back into my my 3D point cloud program again here, we're basically talking about how far, if I was doing a measurement of an object that was right here on the roadway, the question is how far is that from the camera? So I'm going to remove my other lines here just to hide them, to not get too confusing. If I wanted to create a measurement that said, where is that particular line right there from this point, I want to project that back to the camera. So if I project this line back to the camera and I say that the distance between the camera and that line is 225.59 feet, and I wanted to assess my margin of error, well, I'm realizing that it's within this area of interest, so I have to take that distance from the camera and multiply it by 0.005 feet to get my scanner accuracy. So back inside of my measuring program, I have that number there that I'm going to bring into my calculator to say 225.59 feet times 0.005 is 1.13 feet. And then I'm going to add that together with this value here to get my final margin of error. So plus 2.8144 feet. Basically, 4 plus or minus 4 feet is my margin of error on this particular area of interest. Again, keeping in mind that this is going to be much lower than that if I went through and more carefully picked my points. I think that when I did this process in more detail, the margin of error is closer to 2 and a bit feet. But hopefully this helps provide you with a perspective on how this process is done. We want to create a calculation that addresses all 3 of our potential factors for margin of error. The first being scanner accuracy, which is going to be interpreted by the distance from the camera times the numerical value, the calibration accuracy, which we automatically calculate in the program, and the resolution accuracy, again, which is automatically calculated in the program. Calibration accuracy, again, this is in much more detail in the webinar, but the calibration accuracy refers to how accurate the overlay is to the background, and the resolution accuracy refers to how many feet per pixel are in the target area of interest. I recommend that you get a chance to experience that process on your own as well. It's one of the big pieces of value in the tool is the way that we calculate margin of error. And the reason the margin of error can be broad in terms of a couple plus feet is really to be all-encompassing and to ensure that when we are addressing the distance traveled by a vehicle, that we're really taking into consideration every single piece that can address error. Okay, I'm going to remove that line here and move on to the next step. So now that we've calculated our margin of error, you'll notice that input ACE has taken us right back into step 4. So we basically, looking at these steps here, we have a series of steps, step 2 being the area where we correct the lens distortion, step 3 where we pick our points to do the correspondence points, step 4 where we can crop our overlay, and kind of as a sub-step of step 4, now that we're done, we can do a series of 3 steps to calculate the margin of error. So this particular button kind of pops us out into a separate area to do margin of error calculation. And now that we've done all the steps involved, we can go on to our next step. It's going to ask us to save our camera match, which if you recall the camera match file here, I'm going to say this is my camera match example file. The camera match is the way that we can reload within input ACE to set us right back to this process here. So if I close all this down and I shut down input ACE and I close out the program and then I, at a future date, relaunch input ACE and I want to get working on that particular process again, once input ACE is reopened, I can go back to my camera match tool on the tools page under camera match and I can reload that camera match file and it will now restructure all of the bits and pieces here to realign everything and get me ready now to process that onto a video file. So I'm going to load back in here my clip that we had, because basically what we have now is a series of steps inside of this particular region that I'm going to batch process on any of the files that I want in my file list. So now I can do this on a video sequence, I can do this on an image sequence, I can do this on a full video file, by simply connecting the line between my clip and the camera match. And this particular output here is going to batch process those same steps on every single frame of video. And the process starts by pressing the execute button down in the bottom right-hand corner. Now we are creating a new type of file output. So what we've looked at before is the camera match file, which is of course the saved steps to recreate the camera match. Now what I'm creating is an overlay sequence file. And the overlay sequence file is what we're able to launch and overlay on top of our point cloud. So once this process is done here, where it's finished going through every single frame of video and processing those steps on every frame, we're then going to be able to launch our overlay and load in that particular image sequence. Instead of waiting for the couple minutes it would take to process this, I'm going to launch the overlay on a previous calibration step that I've done. And so you can see here that after pressing the launch overlay button, which side comment here, you can also open that overlay button from the options menu here. It's the same button. It does the same thing. And if I load in an overlay sequence button, we've now essentially left the primary interface for input A's, and we're in our overlay interface now, where we can take our overlay and bring this back on top of our point cloud. And so what you'll notice here is that we have our video that's been calibrated, and we have our point cloud in the background. The reason this is set up in this way is that we can go back into our point cloud tool. We can go, I'm going to move this overlay just out of the way so that we can see our point cloud tool. And if I want to go back into my right-hand camera, which I saved a bookmark of that particular view, I can see the way that this now appears. And what I'm going to want to do is take my overlay file and line this back up on top of the original point cloud. To help with this process, I'd like to set my transparency or my opacity so that I'm about 50% roughly. And now as I move this item in, I can begin to nudge this back into place. So if I get as close as I can to where it should be back in place, what we'll find is that once we've locked this in perfectly, we'll see that there's no difference between the overlay and the background in this region of interest around the outer edges. So what I like to do here is toggle back and forth, and you can see very subtly that my overlay is up and to the right a little bit more than my background is. So I need to nudge it back to the left and down a little bit. The left and top pixel coordinates here are specifying where on my screen my left-hand corner area is. So if I want to move this to the left, I need to reduce that number because 0, 0 is going to be the top left-hand corner of my monitor. So right now I'm at 272 pixels and then down by 97 pixels. And if I'm noticing that my overlay is up and to the right too much, that means I need to reduce this number, and I need to increase this number to get it lower. Let's see if I got closer. I'm still going to be, now I'm down to low, and I need to move to the right. So I'm going to move this to 271, and I need to move this to the right by increasing the numbers. Let's go up to like 100 there. And now I am far too low, so I might be going in the wrong direction here. Let me rethink through this. If I need to bring this back up, I need to reduce this number. Let's go to like 97. Sorry if this is confusing. And I still need to go down now. So I'm going to increase this number to 98. And now, as I go back and forth, I don't see any change between my background and my overlay. So now that I've locked this in, I want to take a record of these two numbers so that I can recreate this in the future very easily. And now the benefit here is that I'm able to see the image of the video on top of the point cloud as I go back and forth. And here now comes in the primary power of this tool and really the area that provides us with the most value. Because what I'm able to do with my overlay is go into a locked state. And once I'm in a locked state, I can still adjust the opacity, but the real benefit now is that I'm able to perform mouse clicks in this area where now I'm affecting my background program and no longer affecting the overlay controls. So if you recall, when I'm in an unlocked state, if I click and drag my mouse, I'm going to move the overlay window because I'm interacting with that overlay window. When I go into a locked state, I'm now affecting my background program. So now if I were to go into an opacity and I wanted to identify, for example, the location of the tire of this vehicle, I can set, in this case, a landmark point where I create a landmark inside of my point cloud. And I can now move that landmark around and really begin to measure where objects are and recreate points. Because you can see here that what I'm doing essentially right now is the same thing as if no overlay tool were present. And I'm clicking around and setting marked points. When I'm in a locked state, I'm just able to visualize my overlay while still creating any interactions that I want within the program. So if you recall from the more thorough hour-long webinar, this is where we were moving a full point cloud of a object, like a vehicle, and moving it and nudging it back into place. Again, I'm not going to go through that process in too much detail. I suspect that you all have a good familiarity of that from the other webinar. But the last point that I'll mention here is that this came up as a question that I didn't address in the webinar very thoroughly, is if you're trying to create measurements of objects that are out in the background. So for example, let's say I want to use my buttons here to move forward frame by frame by frame, and we see our bus come into the view frame by frame by frame forward, and I wanted to measure the location of the front light of that bus. Well, the front light of that bus is above the area of the roadway, and so many 3D point cloud tools, depending on which one you're using, won't allow you to simply project a line out into space. So one of the ways that we can do this, if we wanted to identify where that object is, one of the techniques that I like to use here is I'm going to go back into an unlocked state. I'm going to go back into my my other tool here. I'm going to set my opacity to see-through. Excuse me, I'm going to go back into a locked state so I can affect my point cloud tool. And now that I'm affecting my point cloud tool again here, what I'm going to do is quickly create a plane. This particular tool allows me to create a plane on any two-dimensional axis that I might want. And now that I've got this plane of two-dimensional view, what I'm going to do here is make it a little bit larger, and I'm going to move it closer to the camera. And now that I've got a two-dimensional plane in view, what I can do is bring back my overlay image in. I can then set my my landmark point to try to be directly on top of that light. So I'm going to move my mouse into the area of the light. I'm going to click, and now I've specified a two-dimensional point where that light exists. Now that that's done, I'm going to take my overlay opacity away again, and I'm going to take a line and project it directly to that point, and then into my camera perspective. Now I can take that exact same line, I can remove my plane or hide the plane, and then I can take this line and I can project it out into space to show that right there is where my light of my vehicle is intersecting. So in that way, I've taken a new line, marked it on the plane, and then projected that out into space. And now I can say that if I go back into the perspective of my camera, I can create a vehicle or a measurement that shows right within a two-dimensional line where that particular light exists of the vehicle in question. Okay, I know that was a lot to go through in the 50 minutes that we've done. I even went a little bit over from what I was hoping to do. This tool, I hope that what you can see is that it will take a little bit of practice to become a quick expert on it, but I hope that the tool is easy enough based on the descriptions that we have and the intuitiveness of the interface. So I'm going to open this up to some final questions for anyone who wants to dive into anything that they've seen here. Please don't hesitate to take the next few minutes to send in some questions. One thing I'll repeat while I'm waiting for some questions to come in is the three different files that we are saving out of the program. One is the camera match file, and that is the file that basically stores all of the steps. Step 1 through 5 and the margin of error correction, so that we can reload that data and again repeat our process or use that same technique on another sequence. In addition, we can use that sequence on a number of clips. So for example, we might have a long video file that is many hours long that we create 5 or 6 clips from, and we can now process those same calibration steps through each of those clips. That's the camera match file. Another type of file that gets created is our margin of error file. So I go back into step 4. We create the margin of error file by popping out into the margin of error steps, where we go through those sequences that I discussed earlier in this presentation. From here, once we press save, it will prompt us to save our margin of error, and it will create a new PDF, and that PDF will show us how to calculate the margin of error for any of the areas of interest. So any of the measurements I'm doing in this region here are going to have a different margin of error than this region here. And we'll see that the margin of error actually gets bigger for the areas that are further away from the camera, which is what we would expect. In addition, when we save that process out, we also have individual images. So we get a single PDF file, like this PDF file here, but we also get a folder full of individual bitmap images. That way we can take these images and we can use them in a report and refer them back to the actual PDF in question. So that's another type of file that we create with this tool. The third type of file is the very last step, where we create a camera match, where we create a overlay sequence file by going through and running this. And this process, when we create our execute button here, will create a new overlay sequence file, and that is the particular file that gets loaded into the overlay. So if you look back into my overlay controls, this particular file, let me close out of this. This particular file here that gets loaded into the overlay is an overlay sequence. And you can see it has a sequence of images that were created through that process there on step 5. Okay, one of the questions I see that comes in is, so instead of marking a point on a plane, so if I go back into my point cloud tool here, I performed a particular technique where I marked a point on a plane and projected through. That is not a required step. That is just a particular trick that I like to use oftentimes when doing this process. Another technique here, of course, would have been to have a full-scale object of the bus that we are then moving in scene to get it to line up with the background. That is a much more common step than the point cloud plane process is. But I think this plane process allows us to be a little bit more fine-tuned. So just a little tip and trick that I like to use, but certainly not a required step. But that's a very, very good question. Okay, another question is if we've ever used the workflow on a moving camera. And yes, the process it can be used on a moving camera. However, it is going to be a frame-by-frame specific approach. So if you have a moving camera, we are unable to do a batch process of multiple frames through this process because it will be a unique camera match for every single frame when the vehicle is moving. If you want to see an example of that, we did go through that on the other longer webinar where there's an image from a drone that we were using. But if you notice on that webinar, it is a single static image from the drone and not a video sequence. Again, I know that something that someone might assume is that a single camera is going to need to get corrected and calibrated in the same way every time, right? Well, although that's an assumption that I think a lot of people will make, the way that we are performing the camera match overlay is taking into consideration that we are not going to necessarily be at the exact point of origin of our original camera. We're going to be close, but we're not going to be at the exact same perspective. And so because of that, our margin of error takes into consideration any of the issues with being off of the camera perspective. But it does mean that if you're trying to address the point of origin of a moving camera, your point of origin is going to be different subtly from image to image to image, which means that the camera match overlay process that we're doing is also going to need to be different frame by frame by frame. It's a very manual process. It does take quite some time, but we have done that process before on moving cameras. Okay, I see another question. How much does the final result depend on the accuracy of the original background image you capture being close to the same perspective? How much does it account for? Quite a bit. The margin of error that we are calculating will increase exponentially depending on how far off you are from the camera. And feel free to play around with that, right? If you want to take a quick experience of that, get as close as you can to the point of origin, and then move your camera a little bit and try to do another margin of error correction. You'll notice that a lot of the lines in the background will start to become a bit wavy. So first off, visually, it will not look nearly as appealing. But then also mathematically, you'll see that the margin of error will begin to increase very rapidly because of how those images are being corrected. So yes, in short, it does matter pretty substantially. And so the further off you are, the higher the margin of error will be. Okay, the question is, how are you able to animate the point cloud? So on the other example on the last webinar where we were doing a fly-through, that was simply, there's a couple of different ways to do that depending on what tool you're using. I know that both Cyclone and Ferrocene have the ability of creating animations. I've even done things as simply as setting up bookmarks in a point cloud and then recording my screen with a screen capture utility, and then recording the screen and then transitioning into a new perspective. So something like that to then create a clip. And I should, I'm gonna pivot here and just talk about how we normally put all this together. What I normally use is I'll use a simple editing tool like a Premiere or a Camtasia or really anything like that, where I'll create a number of clips and then put them together. So I might create a single clip that is a screen capture of this. So there's my clip 1 that is now completed. And then my second clip that I'll bring in is my overlay, which dissolves in and then plays through the video. And that'll be my second clip. And then I'll pause and dissolve out and then create some third clip that flies over to a new perspective. So in that way, we're able to create these nice demonstrative clean exhibits by incorporating our point cloud with the overlay that we've produced within Input Ace. Okay, I'm seeing a couple of additional questions come in that are probably outside of the scope of what I wanted to show today. So if you have any additional questions that I wasn't able to answer, please just send me an email. I'll talk to you guys individually about any of the more technical questions that you might have, just to make sure that I don't go down a confusing rabbit hole for some people. Okay, so I'm seeing the trickle questions is beginning to subside here. So please, again, don't hesitate to email our support team. I look forward to any feedback that you all have on your experiences with the overlay. I know that we're getting quickly approaching our expected launch date here at the end of January. So if you have any comments or questions or suggestions of things that we can tidy up and polish and add to the tool before we release, we're absolutely all ears. I really appreciate everyone being so willing to partake in this beta program, and I look forward to the responses that you have. Thanks again, everyone, and I hope you have a great week.